Hey guys, so today I'll be doing the 2012 AP Calculus FRQ number 2. So let's just hop right into it. So this problem gives you this graph and it says, let R, the region in the first quadrant bounded by the x-axis in the graphs of y equals ln of x and y equals 5 minus x as shown in the figure below. So A says, find the area of R. So to do this, what we need to do is we need to find this intersection point. We need to figure out what that is. So to find this intersection point, we need to use our graphing calculators. So we'll go over here, we'll turn it on, go to y equals, then we'll plug in the formulas that they give us. So y equals ln of x for the first one. The next will be y equals 5 minus x. 5 minus x. Then we'll hit graph. Alright, now after this is graphed, we'll hit second right there and trace to give us calculate. We'll go down here to intersect. We'll hit enter. Find the little cursor. The cursor's on this graph, so we'll hit enter. Now the cursor's on this graph, so we'll hit enter. It'll find the intersection points of those two graphs. It'll ask guess, hit enter again, and it'll give you this point right here. So to make our lives easier, we're going to call this point A comma B. So I'll write that down. Alright, so now that we have this point written down, we can finally solve for the area of R. So there are two ways to do this, but for time's sake, I'm just going to show you how to do it one way. So we're going to start off with the integral from 0 to the y value of that point. So from 0 to b, which you can see there as 1.30656. So by doing this, it's like we're taking the area from the bottom of the y-axis and going up. So we only need one integral for this. So what we'll do is it'll be integral from 0 to b, but because we're using the y value, we need these equations to be in terms of x. So we have the equations y equals ln of x and y equals 5 minus x. So what we need to do is we want to isolate the x variable. So here we'll just e both sides, and we'll say x equals e to the y. And over here what we can do is we can just subtract 5, which will go to y minus 5 equals negative x. Then we can just multiply the whole thing by negative 1, which will give us 5 minus y equals x. So now that we have those two equations, now we can plug them into our integral. So we're going to use the outer limit first, which is going to be this line right here, y equals 5 minus x, or x equals 5 minus y. So we'll say 5 minus y. Then we'll go minus again of the inner limit, which is going to be e to the y. Then, of course, dy. And you can just plug this into your calculator, and you should get 2.985 or 2.986. Alright, so now we're on to part B, which we're dealing with cross-section. So pause the video for a second and read that little excerpt. Okay, so the equation for the cross-section of a square is simply s squared, and because the cross-sections are perpendicular to the x-axis stated in the problem, we can use the equations given, which are already in terms of x, which are these ones that I circled here. So we can use the equation y equals ln of x, which is this, up until we hit this point right here, because that is the x value of the intersection point. And from right there, we're going to need to change to using this equation. So we'll have two separate integrals in this problem. Alright, so our first integral is going to look like this. From 1, because that is where this graph crosses the x-axis, the first graph, it's going to be from 1 to a of just the first equation, ln of x. But remember that's going to be squared because the equation for the cross-section of a square is just s squared. So this is the s and you're squaring it. So then you're going to say plus integral from a, because again that is where the x value of the intersection point is, to 5, because that's where the end of the graph is, of 5 minus x all squared. And remember the dx there. Alright, so now we're on to part C. So to find the value of k, in which y equals k, at which we'll divide the area of region R into two regions of equal area. We're going to set up an integral identical to that in part A, except instead of the boundaries being from 0 to b, the integral will be from 0 to k, and k is what we're trying to solve for. And we'll already know what it equals, because we'll set it equal to 1/2 of 2.986, which is 1/2 of the area of the region R. Okay, so this is the expression which you should have set up with the integral from boundary 0 to k of 5 minus y minus e to the y dy equals 1/2 of the region of R, which is 2.986 or 2.985.
This is multiple choice 1, number 79. For 79, the problem states, let f be a function such that limit of h approaches 0 of f of 2 plus h minus f of 2 all over h equals 5. Which of the following must be true? Number 1, f is continuous at x equals 2. Number 2, f is differentiable at x equals 2. And number 3, the derivative of f is continuous at x equals 2. Since we know that as the limit of h approaches 0 of f 2 plus h minus f of 2 all over h is the definition of a derivative, and it gives the number 5, the function is differentiable at x equals 2. And if a function is differentiable, that means it is also continuous. Therefore, number 2 is also correct. However, 3 cannot be proven true, since at x equals 2 of the derivative may not exist, proving the definition of continuity false. Therefore, the correct answer is 1 and 2, which is C. 1 being f is continuous at x equals 2, and 2 being f is differentiable at x equals 2. This is multiple choice 1, problem 80. And the question is, let f be the function that is given by f of x equals 2 times e to the 4x squared. And for what value of x is the slope of the line tangent to the graph of f at x f of x equal to 3? So what's it asking is, at what x does f prime of x equal 3? And because f prime of x is equal to the slope of the tangent line at x f of x, we know that we can use this equation. So since we know that f of x equals 2 times e to the 4x squared, then we can find f prime, finding the derivative of 2e to the 4x squared. So first we can take out the 2 because we already know that won't be involved in the deriving. And to derive e to the 4x squared, we can use the equation the derivative of e to the u equals e to the u times e to the u prime. And so by doing that, we would take out e to the 4x squared, which will also be e to the u, and multiply it by the 2 that we already have, and then take the derivative of 4x squared. So next we would take the derivative of 4x squared, which is 8x, and then multiply by 2e to the 4x squared, and get 16x e to the 4x squared. Now that we know what f of prime is, we can plug it into the graphing calculator and say y equals 16x e to the 4x squared, and then we can graph and trace along the line and see that at y equals 3, x is about 0.17, and the closest answer to that is A, which is equal to 0.168. On multiple choice 1, problem 81, the problem is a railroad track and a road cross at right angles. An observer stands on the road 70 meters south of the crossing and watches an eastbound train traveling at 60 meters per second. At how many meters per second is the train moving away from the observer at 4 seconds after it passes through the intersection? So for our train, it's going along here. This is where they cross on the road, and the observer is going to be 70 meters away. And so what it's asking us to find is dz over dt, or the speed the train is moving away from the observer. Since we know that it's at 4 seconds, we already know that y equals 70 meters, and then since the train is traveling at 60 meters per second, we know that in 4 seconds it will go 240 meters. Then using Pythagorean theorem, we can plug in the numbers and get 250 meters for z. Lastly, we can plug in all of the numbers using this equation. 2x times dx over dt equals 2z times dz over dt. And we get 2 times 240 times 60 equals 2 times 250 multiplied by dz over dt. Then when we plug all of those in and solve, we get 57.6 meters per second, which is A.